Hello children, welcome to Raya Tuition Classes. We are doing Standard 10, Icse, Chapter 2, Exercise 2A, question number 21, okay? Now here, from question number 21, okay? Now what is question number 21? Name the physical quantity which is measured in calories. One physical quantity which is measured in calories. And how is it related to the SI unit of that quantity? Please have a look here. Calorie usually is related to is a unit of heat energy. Heat energy is measured. Heat energy. Name the physical quantity which is measured in calories. Heat energy is measured in calories. Heat energy is measured in calories. Okay, heat energy is measured in calories. Okay, children. And how is it related to SI unit of the quantity? SI unit के लिए see 1 calorie is equal to 4.18 joules. SI unit of energy is joules, okay? So 1 calorie is 4.18 joules, children. You should understand this, okay? Now we go to question number 22. Define kilowatt hour and how is it related to joules? So just have a look at this word, children, kilowatt, okay? This word kilowatt, you come across, I mean, it's nothing but unit of power. Remember, unit of power. Kilowatt is a higher unit of power. Power is what, beta? Power is usually rate of doing work. Power is of a source. Power, the source as a power, source which is doing work, okay, per second. That is called as power of the source, okay? And please have a look here. This R is for the time. So kilowatt hour is actually a unit of energy. Actually, kilowatt hour is a unit of energy. The total together, both are, see, kilowatt is actually a power. R is for time. Now together, kilowatt hour becomes a unit of energy. So how will you remember the definition, beta? So I will say, I'll remember it, it's energy, na? So see here, the amount of energy used, amount of energy used by a source having power 1 kilowatt in 1 hour. Okay, just try to recollect, remember like this. See, kilowatt hour, these two words, this is a unit of power and this is a unit of time, but together when they come, it becomes a unit of energy. So how will I remember the definition? The amount of energy used by a source having power 1 kilowatt in 1 hour. Got it? Now, how is it related to joules? So 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. Got it? 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. Got it, children? So very simple, children. Try to remember. Okay. Sure. Question number 23. Define power. State its SI unit. So power is, what is power, children? Power is the amount of work done in 1 second, I can say. Okay. The amount of work done by source in 1 second is called power of the source. Okay. Or I can say power as the rate at which the work is done. Power is defined as power is the rate at which the work is done. Rate at which the work is done. Right? Rate at which the work is done. Okay. In other words, I'll say speed of work it is. It is nothing but speed of work. Speed क्या होता है? Distance per unit time. We say work per unit time. Work done per unit time is power. Are you getting me here? So that speed at which the work is done, we call that as power actually, okay? Now, what is SI unit of it? SI unit of power is, SI unit of power equal 1 watt, okay? watt. Okay. Now look here, children. It's a unit of power is watt. You need not say 1 watt, yeah? Watt, okay? Now look, we go to the next question. State two factors on which the power spent by a source depends. Okay. Now see, like everywhere in every chapter, you're going to remember this. These questions are asked: factors, factors, factors. There's nothing to get confused. There's nothing to worry about. You know, I told you, power is what? Just like I told you, it's like speed. Speed is distance upon time. So power is nothing but speed of the work. मतलब कैसा होएगा? अरे power is work upon time. ऊपर work है, नीचे time है. तो पार अगर वर्क अपॉन टाइम है तो ये दो फैक्टर हो गया बेटा उस जिसके ऊपर डिपेंड होएगा सो सिंपल द फैक्टर्स ऑन व्हिच द पावर स्पेंट बाय सोर्स डिपेंड्स आर द वर्क डन बाय द सोर्स द factors on which the power spent by a source are so you can remember the formula bit of what I've done here, okay? Work upon time. So the factors on which the power spent by source are 1, work done by the source, and secondly, the time taken by the source to do the work. Time taken by the source to do work. So I can, the other question is explain with the help of an example. Okay, they want me to give an example for making you understand this factor. Simple, children. Like suppose I'll put it like this. Got it? A person I'll put it slowly. I'm so sorry. Okay, wasting your time here, but doesn't matter. I have to rub it off. Okay, like examples. Okay, with the help of example, I would like to explain this. Okay, like a person does a work of okay 1,000 joules in 1 second, while a boy does the work of 1,500 joules in 1 second. Hence here the work done by the boy, is more, hence the work done by a boy in 1 second, is more than the work done by the man in 1 second, Hence, the boy is said to use greater power. Boy is said to use a greater power. So hence power depends on work. Okay, depends on amount of work. Okay, so you can see here a person does a work of 1,000 joules in 1 second, while a boy does the work of 1,500 joules in 1 second. Hence here, the work done by the boy is in 1 second is more than the work done by the man in 1 second. Hence, the boy is said to use greater power than the man. Hence, power depends on the amount of work done. Okay. In the same way, beta, this was for the first one. Got it? Like a boy, he reaches a boy carries I'll tell you, uh, uh, okay, I want to wrap it up. I'm so sorry, children. I don't have, please. I was thinking double mind. Okay, so the time of yours gets wasted. Okay, I'm so sorry, but just look here. I'll put it like this: a boy carries a mass of 20 kgs to the third floor of a building in 5 seconds. Okay, it carries in 1 minute. Okay, whereas the same amount of mass was carried by a person, the same mass was carried by a person to the same height in 2 minutes. That means here the work done by both of them is same, but the boy has done it an earlier time, less time. Hence, he is said to use a greater power. So, power also depends upon the time. Okay. So, I'll just say, please have a look at the second one, beta, which I rubbed it off and taken time. Okay. A man does, I'll say, put it like this: a man, second one. Okay. Second one. Okay. A man carries a certain load to the third floor of a building, in 2 minutes. In 2 minutes. Whereas a boy carries the same load to the same floor in 1 minute. So here the work done by the man and the boy is same. But the boy has done the work in lesser time. Hence, he is set to use. Hence, the boy has used greater power than the man. So here you can see the work done. The work done was same by both of them. But one boy has done it in lesser time, man has taken more time. So naturally the power used by the boy is greater. So here the power depends on the time also. Hence, the power depends on time also. I hope everybody understood better. They said, okay, on to what factors does the power of a source depends, and I explain it with the help of examples. So I just straight away said the two factors first. It depends upon the time work. It also amount of work. It also depends upon the time in which the work is done. And separately, I'm trying to show both examples. Okay, I hope people have understood it. Here, a person does a work of 1,000 joules in 1 second, while a boy does a work of 1,500 joules in 1 second. So when you see, hence here, work done by the boy is more than the work done by the man in 1 second. Hence, the boy is said to use greater power than the man. So power depends on the amount of work. Whereas here, a man, second one, just have a look at it. A man carries a certain load to the third floor of a building in 2 minutes, whereas a boy carries the same load to the same floor in 1 minute. So here the work done by the man and the boy is the same, but the boy has done the work in lesser time. Hence, the boy has used greater power than the man. So hence power depends on time also. I hope everybody's understood it. Okay. We go to the next question. Question number 25. Differentiate between work and power. So here, when you say work and power, okay. Now listen, work with the first one, we can always be the definition, okay? You can say, what is power beta? Power is the rate, power work is defined as a product of force. Work is, the work is the product of force and displacement in the direction of force, whereas when you go for this direction of force, so here you'll say power is the rate at which work is done. So both are, the first will be always the definition. Got it? If we have the first one, will be always the definition, children. The second point, you can always, please here, don't see the units. Got it? Never. Some teachers don't give marks for the units. Got it? Some children write the units of both are going to be different. Okay? But they don't give marks. So here, work does not depend on time, on the time. Work does not depend on the time, where power depends on time. Power depends on time because power depends on time. Depends on time because it is the time in which power depends on time because it is like you can say power depends on time because it is the work done in unit time. It is the work done in unit time. Okay, I will not go for the next. Some people will write, the textbooks also give, okay, Julia. Here you can say joule per watt, okay. SI unit you can write, but some teachers, I didn't know why, but I've seen them. They don't accept it immediately. The units as a point for difference, okay. They want the definition, some better points. Like here, differentiate between energy and power, okay? Differentiate between energy and power. So here the answer, energy as well as power beta. Just like work and power, energy and power. Energy of a body, see, energy is the capacity, of a body to do work, okay? To do work. Got it? Energy is a capacity of body to do work. That is energy of the body, okay? Whereas again, if you ask me, yeah, instead of using the work, I'll say it is the rate at which the energy is spent. Okay, I hope the same thing. Power is the rate at which the work is done. The same thing. Power is work. Okay, I mean, energy is nothing but work. So it is the rate at which the energy is spent. Got it? It is the rate at which the energy spent. Again, the second point is common. Energy does not depend on time. It does not depend on time. There is no energy, it's just capacity to do work. There's no time involved, okay? Whereas it depends on the time in which the energy is spent. Okay, so I just give 2 points for it. Okay, and then, but very important question, beta, you can expect this question in your exam. Question number 27. Okay, state and define the SI unit of power. State, you have to state first and then define the SI unit of power. Well, state the SI unit of power, define the SI unit of power. So what is SI unit of power? SI unit of power is watt, capital W. Okay, now I want to define it. Okay, so how will you define it? Children, always remember, you cannot learn by heart. Okay, thousands and thousands of definitions you should learn, but you cannot learn it by heart. But one thing, power is work upon time. So work का क्या है बेटा? Joule और time का क्या है? Once again. तो आपको खाली language आनी चाहिए. Power spent by the source. Am I right? Okay, so yeah. So the power, see, when 1 joule of work is done in 1 second, then the power spent by the source is said to be 1 watt. What is 1 watt? What is? So yaad rakho beta. See, SI unit of power is watt. Now I want to define it. 1 watt. Okay. See here. So simple beta. When 1 joule of work is done in 1 second, then the power spent by the source is said to be 1 watt. Okay, I hope people understand me here. You can always remember, okay, power be spent. Okay, so we should use the language, take care of the language. Okay, the next one, question number 28, children. Now, what is this question number 28? Okay, children, let's see read and see. Question number 28 says, name a physical quantity measured in terms of horsepower. Oh, just one liner it is. Physical quantity, okay? Power is measured in terms of horsepower in mechanical engineering. Okay, mechanical engineering means when we talk about power of the machines, okay, big machines, we'll talk in terms of horsepower. Got it? Power of the big machines, we'll always talk in terms of horsepower. Okay, now what is this? 1 horsepower is equal to 1 HP is equal to 1 HP is equal to 746 watts. Okay, 1 HP is equal to 1 horsepower is equal to 746 watts. Question number 29. Differentiate between watt and watt-hour. Watt and watt-hour. So what is watt? Bit of watt. First point I'll say, watt is the SI unit of power. Okay, and what is this watt-hour? Watt-hour is a unit of, don't call it SI unit, is a unit of energy. Is a unit of energy. Got it? Unit of energy. Now the second point, what I can see, like 1 watt, like, you know, in terms of 1 watt is the amount of work done in a unit time, okay, amount of work done in a unit time, correct? Whereas 1 watt hour is the energy spent by a source or having power 1 watt, having power 1 watt in 1 hour. 1 hour, okay, children? To remember this, children, 1 watt is the amount of work done in a unit time, whereas 1 watt hour is the energy spent by a source having power 1 watt in 1 hour. I think fairly simple, children. These 2 points should fetch you enough marks. Now, name the quantity which is measured in kilowatt hour. So what is this? Kilowatt hour, okay? Which energy? Energy. Quantity. Name the quantity which is measured in kilowatt hour. So these are the units on the left hand side. And I'll put it like this. 1 minute, children. I'll put it like, these are the units here, and quantities measured. Quantities measured, okay, in those units, okay? Like, first one, A1, what it is? Kilowatt hour. So I think this is energy, because it's a commercial unit of energy, kilowatt hour. Now, B1, kilowatt, it is power, higher unit of power. Got it? Now, again, watt hour. Watt hour is again energy. Okay, and electron volt, I'll special again energy of atomic particles, energy associated with atomic particles, energy associated with atomic particles, okay, children? With this, your exercise 2A gets completed. Exercise 2A gets completed, children.